So, hi Math 8, welcome to class. So as I had mentioned last week, I'm going to be gone Monday and Tuesday of this week. I'm out at the John Prince Research Forest with the Geos 11 and 12 class. You might see me in the building in the mornings quickly picking up some things, but I won't be there for class. So I've left a copy of the notes and I've made a couple of videos. I would like you to have those notes out in front of you and be filling them in as we move through this lesson. The next couple of days are going to be spent on slope, Y-intercept, and then building those linear equations and interpreting kind of real life graphs. So looking at this first set of questions, it asks us to determine the slope and Y-intercept of each line and then to write the equation. So we know that our linear equation is given by y equals mx plus b, where m is our rate of change or our slope. So we're kind of calling it two things, so rate of change, also known as the slope. And then B is our constant, but on Friday I introduced this to the idea that it could also be referred to as our y-intercept. In other words, where the graph crosses the y-axis. So let's try to identify those two values based on this graph, and then we'll write our equation at the end. So we know now that slope is given by the m, and it is essentially the rise over the run. And going back to last week, I can introduce you or reintroduce you to the little slope man. So let's make a crabby Mr. Slope. So if the line goes down like that, it's a negative slope. And if the line goes up as you move from left to right, it's a positive slope. And then we've got our straight vertical nose. That should be a little straighter. It's a little hard to write on my tablet. That's going to be an undefined slope. And then we'll have his flat mouth, and that's going to be a zero slope with the two little O's on the end. So that's Mr. Slope. So looking at this graph, we can see that it's going to be a positive slope. So our number in the end should be positive. Now, going back to our formula, m equals rise over run. In order to plug this formula in and figure out the slope, we need to pick two clear coordinates on our line. So I'm going to zoom way over here and I'm going to pick this coordinate. This is actually our x-intercept. It's where the graph crosses the x-axis. And I can see that it runs right through that point, and it's going to be -9 and 0. So -9 on the x-axis and 0 on the y. Now, if I zoom along that line, then I can see that there's some other clear points. There's a clear point right here. There's another clear point right here. There's another clear point right here, and here, and here, and here. It doesn't matter what other clear coordinate you select to calculate your slope. You should get the same answer no matter what. Now, just to make this nice and easy, let's go ahead and let's pick this as our kind of our second coordinate that we're going to work with. And that would be at 0 on my x and +3. Now, how do we get from the most left point, the -9, 0, all the way to my most right point that I'm working with, which in this case is the 0, 3? Well, the first thing that we'll notice is that I have to rise. So my rise is going to be positive. I'm going up. So how much am I going up? And go ahead and draw the little bubbles like we did last week. So 1, 2, 3. So it looks like I am rising 3. So my rise is going to be a +3. How much am I running? So in other words, what's the horizontal distance that I'm moving then? So again, do your little bubbles. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and it looks like 9. And I'm moving in the positive direction, so it's going to be a +9. Now, once I get to this point, I can ask myself, is there something I can do to clean this up? It's like a fraction, right? And I could reduce or simplify this fraction by dividing my numerator by 3 and my denominator by 3. So that ties in some of that fraction terminology that we learned earlier in the year. So +3 divided by 3 leaves me with a 1. And +9 divided by 3 leaves me with a 3. And those are both positive. We don't have to write in that positive sign, but we know that my slope is going to be +1/3 overall. In other words, for every one jump that we make, and I'll actually just change color here to show you, for every one rise that you make, you're moving over 3. Okay, so you can see that the slope is the same anywhere along that linear line, as long as it's a linear line. You're rising 1 and you're going over 3, running 3. Okay, so that's our slope. Now let's do our y-intercept. So I'll try to go back and pick the color I had. So the y-intercept is where the graph, the linear equation, crosses the y-axis. So here's my y-axis right here, and so we just zoom down until the line crosses that x-axis, and you can see that it's this point that I've already identified. My y-intercept is positive 3. We write just the y coordinate for it. It crosses the x-axis, or sorry, the y-axis at positive 3. Okay, so once we get our slope and our y-intercept, we can box those so they really stand out to you. And then we can go and we can write our formula. So we know again that our formula is y equals mx plus b. On our second line, we're going to substitute 1/3 in for the m, for the slope, so 1/3 x. And then for the y-intercept, the b is going to be a plus 3. So here is my final equation that describes that linear relation. Okay, let's go and try the next one now. And I'm going to speed up a little bit so I won't give quite so much background information. So let's try this next one. Again, we know that we're looking for our slope first, and it is rise over run. Now, we should be asking ourselves, ooh, is this a positive or a negative slope? So we can see that it's a negative slope. It's going down as we move from left to right. So we should expect our m to be a negative value. So let's identify 2 clear points. And again, there's going to be multiple ways to do this. I'm going to select, just to shake things up, I'm going to select this point, which is at -7, 8. And then I'm going to zoom around along my line until it comes across another one. And there's another one right there, but that's a little squishy to show my demo. So I'm going to go to, what point is it? Let's see here. Goes right through this point really nice. And that is at 0, 4. Which again, you'll notice is your y-intercept. Just gonna erase that for you there. Okay, so let's figure out how we get from our most left point to our right point. Now in this case, you're gonna see that I actually have to go down. So my rise is gonna be a negative number. Let's count. 1, 2, 3, 4. I went down 4, so my rise is actually a -4. So I'm going to substitute that -4 in for my rise. And then my run, let's see how much I move over. 1, 2, 3, 4, 5, 6, 7. It's a positive 7. So I end up with -4 over 7, which doesn't reduce, but I can clean that up just how I write it a little bit. That negative can just be assigned kind of to the middle there. So it's -4/7 would be my slope. And then we can look at our y-intercept, and our y-intercept again is just where that graph, the line crosses the y-axis. And so you can see that it is right here at +4. So my y-intercept is +4. My equation then following our standard linear relation is y equals mx plus b. So y is going to stay. I'm going to substitute -4/7 in for my m. I have an x, and then I have a +4 on the end. And I'm going to box that answer. Fabulous. Let's go down and do one more. So same process here. Again, ask yourself, is this a positive or negative slope? And then kind of work through it, and I'll go through it in just a minute, but pause the video now, try this one on your own, see what you get, and then you can watch the video. I'll go through it quite quickly, and you can just make sure that you've got it correct. Okay, so pause the video. Okay, so hopefully you've had a chance to try this on your own. Let's see if you get the same thing that I do. So we know that our slope, is our rise over run. Now, Each of you may have picked some different coordinates to work with, and that's okay. Our slope should be the same no matter what coordinates we selected to work with. So I'm going to pick this point over here, which I know is at -9 and 2. And then I'm going to zoom across and I'm going to pick, I'm going to pick this point right here, my x-intercept. And it is at -3 and 0, my x-intercept. So I need to ask myself, how do I get from my left point to my right point? So the first thing I'm going to do is I have to go down. So how much am I going down? Oh, it looks to me like I'm going down 2. So my rise is actually a -2. And then I got to ask myself, how much am I running? So I'm running 1, 2, 3, 4, 5, and 6. So I'm running a +6. Now from this point, you can see that I need to reduce. So I'm going to reduce by dividing both of these by 2. And that's going to leave me with -2 divided by 2 is a -1. And then 6 divided by 2 is 3. So -1/3. I'll box that answer. Now you can do a quick little check and you can pick another point like over here and you can say, okay, to get to this next point, this next clear point, I've got to go down 1 and over 3. 1, 2, 3. Hey, that totally works. Yep, that's the right slope. Okay, our y-intercept then, simple. Look to where the graph crosses the x-axis, or the y-axis, sorry, and it crosses it right here at -1. So my y-intercept is -1. When I go to plug in my equation, y equals mx plus b, I keep the y, I substitute in -1/3 for my m, I leave the x, and then I have a -1 for my b. Fabulous. So hopefully that went all right for you and you have the same answer as me.